Everyone, today's the Mur Ligases meeting, October 2024. We have the agenda, and here I think the most important progress is Adrian's latest biological data. Adrian, do you want to take the notes? Yeah, thank you.
Very kindly reporting it like that. Right. So, if I share my screen.
Yes, please.
Which means that I think you have to stop sharing, I think.
Yeah, already done.
Okay. Okay. All right, we can all see this. Yeah. This is an update from the last meeting. It actually contains data that I've already sent through, so you may have already seen it. So I'll walk you through what we've done since we've last talked. So the first part of this are further evaluation of pyrozoal pyrimidines, that is to say, the Pseudomonas aeruginosa MRC inhibitors that Yuhang has been working on. I always put in the assay details of what we do, which is basically this box here. The results of what we've done, though, basically, they concern the series of compounds at the top of the slide, which are amine derivatives of the pyrozoal compounds, and one compound which basically has an ether appended to that position. And essentially, they all have IC50 data, but it's really, if you look at the data, the presence of an amine, a straightforward positive charge hanging off the larger of the two rings, has a very significant impact upon the potency of the compounds. And in actual fact, compared to some of the parent compounds, which I've previously worked on, where we have IC50s that are submicromolar, the presence of that amine significantly impedes the ability of the compounds to act as inhibitors. The compound on the left-hand side, essentially with that sort of butyl ether hanging off the larger ring, that has the lowest IC50 of all, which of around about 5 micromolar, 4.5 micromolar, which compares to some of the weaker binding compounds in this class that we've had previously. Making the assumption that they're ATP competitive, the IC50s translate to Ki values in the region of 2.48 micromolar for the butyl ether compound, going all the way up to 0.2 millimolar for the least favorable amine. So that's what we have there. The second piece of work that we did was for Northeastern University, the compounds that they sent, which we screened versus Pseudomonas aeruginosa MRD, the second batch of compounds we've had. They're based, as I understand it, on a hit that we extracted from the enamine library, which is the compound at the top with the two arrows coming out of it. And we were sent 10 compounds, most of which were derivatives of that compound, to test. So this is a workflow of what we do. So we take the compound, we suspend it in DMSO to 50 millimolar. We then, because experience has taught us that this is a good idea, we pre-screen for interference of the assay. And we have two assays we're talking about. At the top, we have a 10 microliter fluorescence assay, and we screen the compound at 0.5 millimolar. If none of the compounds exert anything greater than 50% activity, inhibition, we know that the assay will actually accurately reflect MRD activity, and so we can assay the compound at that concentration. If, however, we do get significant inhibition, i.e. greater than 50% of the coupling enzyme system, we pre-screen at 0.1 millimolar, and those compounds that show less than 50% inhibition, we then take forward to screen with Mur-D. Anything that completely fails to get through that triage, we have a simpler spectrophotometric assay, which we then trial against the compound and then against Mur-D. So that's, if you like, the modus operandi. So pre-screening the Northeastern compounds versus the 10 microliter fluorescent assay that we have, essentially all but 4 compounds actually passed that triage, and we can assay at 0.5 millimolar. Compounds 8521, 22, 26, and 27, we assayed at 0.1 millimolar compound. And essentially, under those circumstances, none of the compounds actually gave any inhibition greater than 22%, irrespective of the tested concentration. The positive control, which is ADPCP, gave us about 78%. So the assay was functional in detection of inhibitors, but under those conditions, we didn't pick up any inhibition. So what we then did, those compounds that we could only test at 0.1 millimolar, we trialed those in the much simpler spectrophotometric assay, which basically is a single coupling step with purine nucleoside phosphorylase. And pre-screening those, they basically all passed at 0.5 millimolar. So going on to screen them against Mur-D, under the conditions used, we found one molecule, 8251, that had around about 68% inhibition at 0.5 millimolar. At 0.1 millimolar, there was virtually no inhibition detectable. So the bottom line really is going from an original hit in the enamine library of 26 micromolar, we've got to a stage, unfortunately, where we have molecules that are at best a lot less potent. And I'm sorry to say that's it.
That was a very diplomatic summary right there, Adrian. Thanks for that. I think certainly we were disappointed with the data, but thank you very much for obtaining. You know, I mean, they are a little bit different, these compounds, than some of the parent. I'm surprised we have lost all activity, but, you know, I mean, onwards and upwards. I don't think we're going to do any more with this now. I think the intention would be, if everyone is willing, would be to, there wasn't very much reported in the literature in terms of how to actually synthesize these, and Sam and the undergrads that and Lilith, you know, spent a bit of time and effort actually trying to improve the synthesis. And so I think, you know, we could perhaps write a very short communication, which would effectively talk about the synthesis side of things and then say that they were all inactive, sadly. If you're willing.
I think that's a very, very positive approach.
Perfect. Look, we're going to find a silver lining somehow.
Yeah.
And I'm also very aware that Matt's not here to remind me to do it, to put an issue on the GitHub, and that's very firmly in my court. I apologize that I haven't done it yet. So I'll get it up there with a synthesis, with some synthesis slides and, you know, a summary of all of the compounds that we have sent. I will note that Lilith actually made a couple of errors with the structures. So I'm just, Sam reminded me, and he said he would actually have a look at the slide deck after the meeting, and we'll send you any updated structures, and I'll make sure it's all correct on the GitHub before it gets posted. So
thank you so much.
Thank you very much.
It's also good resilience training for a future career in research.
Look, that's what I keep telling the students. They're like, we didn't make a compound. I'm like, yes, but you learned to optimize a reaction. Nothing was active. Well, welcome to science.
Well, as a supervisor once told me, Adrian is telling you something. And then the supervisor rather cryptically left it at that.
Oh God.
Right. Anyway, there we go. I'm sorry, but we did our best. We really did.
I appreciate it. Thank you.
Okay, I'll stop sharing now.
Next one. Is it anyone else want to update? Laura or
I don't have any positive updates on the crystallography side. It's just a lot
oh,
of
sorry about that.
yet.
It was my fault. Like I didn't include the AZ595 last time. The powder thing. So I'll make up to you this time. Including already 6 milligrams. Sorry.
Okay.
Okay.
Yeah, we're just requiring those compounds that I mentioned, but you're gonna send them this week, right?
Yeah, this week, yes.
Yeah, we
Because
want to have it for the end of the month. So, well, the 23rd, before the 20, no, because we need to do the experiment. So,
yeah.
yeah, as soon as they can be here, yeah, we can start doing the experiment.
As soon as you finish, cool.
Yeah. So, so is that still time for the MICs? And
Oh yeah,
I
they are running your MICs are being run. So they already have them done for 4 bacteria. There are 2 left, and they were doing them this week. So if everything goes to plan, they will not need to repeat them, and then you get the
yeah, amazing. Because I got 2 more new samples, as you guys can see on the on GitHub. Yeah. So that 2 new samples, novel compounds.
You want those for MICs as well?
There are a lot. I'm not sure whether everything can be done by then.
Well, let me know. Talk to Matt about it if you want any more MICs, and send me the list, and I can organize.
Yeah. Also one question, like about the MICs, because like the criteria we're following is trying to target was originated from the E. coli. The Hergen-Rosas paper was based on a massive database, and those results were concluded on basis of the results from E. coli. And the major target in our project is Pseudomonas as a starting point. So and these 2 strains are very different in terms of behavior. Is it necessary?
We are testing both. We are testing both of the MICs. So
okay. Wow, that's perfect. Thank you.
I think if I remember correctly, there are 3 different E. colis. So yeah, and then Pseudomonas. Yeah.
Okay.
There
amazing.
Is, you've got that.
Okay. Thank you so much.
No problem.
Anyone else like the Scott crystallography data? How does either compound in Pseudomonas MUD going, or is there any updates?
So I apologize, I don't have updates from them. I kind of
okay. Yeah, thanks. Thanks, Bart.
Yeah, it's been challenging.
Yeah, I can understand. If needed, I have more solid samples.
Yeah, I bought new screens that just arrived, so I want to put new plates for the new screens. Hopefully we find that condition.
There was the October 1st update from SSGCID of Mur with AMP-PNP coli. That's the last update we've got.
Yeah, that was a while ago, I think. Yeah.
October 1st, my email.
Then I think, am I the last one to report, or?
I think so.
Okay, I just go for it. guys see it?
Yeah.
Okay, so it will be the fourth round of shipment. The first things first, as Laura has requested, I've found the E-waste compounds from our previous master synthesizer, and there were approximately 30 mg, but I did a QC and I repurified it. So approximately currently I've only managed to get 18 mg white solids. There are some remainings on the vials, on the wall of the vials, and a little bit remaining DMSO. So and the compound is a bit difficult to purify if it gets DMSO involved. So it's kind of like reverse phase rejected, normal phase carry out will carry the DMSO through. So 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 I can only ship 18 mg for the moment. But if you need more, I think we can figure it out. And Laura's crystallography data sample, I have 6 milligrams. If need more, I can just resynthesize it. The reason why I don't have more, I don't have like tens of milligrams is because I used it all in the pyridinium trials down which I will explain later. So currently I've obtained for the past months I've obtained these two as a novel derivatives, which is a further exploration on the side chain of the of the pyrazolyl pyrimidine core. The reason I make these two is to explore that solvent pointing site. I've done the modeling, and it showed that these two actually do pointing towards the solvent. With the do pointing towards solvent, but there's a hydrophobic site around it, which holds the benzyl. If you guys can see, if a phenol group. But in these two structures, I just don't put that in. They just don't have it. So I just want to see as a control if these two groups are good enough for the potency or helping the compounds getting into the MUSC. Probably it's not like that many influencing factors in terms of design. The complete analysis is in the last. You can see the 115 Mur Ligases meeting. It's the last time, and for some guanidinium and pyridinium derivatives, this scaffold, this rigid scaffold, is the last one I want to try for the guanidylation. If I didn't make it, then probably we should stop because the potency wasn't quite good. And yeah, so basically on this reaction, I just failed. It turns out that the conjugated amine was paralyzed and it's not quite nucleophilic, so it's not actually working this as expected. Yeah, so I guess we just need to show the LC-mass data or just give them a notice in the paper if we want to include that, saying, hey, sorry, we can't make these guanidiniums because the reaction just didn't work, and we expect no other ways of getting that done. Is that and about the pyridiniums, I've done a series of trials. Initially, we want to. Sorry, why is that? Initially, we want to make the pyridinium. Initially, we want to make the pyridinium part of this AZ595. But the problem is we we were having a hard time of getting the amine derivatives of this compound, then move on, then accumulating enough amines to move on to the next step to get the guanidinium and pyridinium on this side, if you guys can see it. So I've explored a few ways of getting the pyridiniums done. Initially, I was focusing on using the single salt. I self-synthesized it, and it worked fine in some of the simple cores. But when it comes to a paralyzed amine, it doesn't work, obviously. And when it comes to some of the complicated amine structures of AZ's 595 derivatives, we can get the product, but that will not only sacrifice the yield, but also having a lot of impurities, because the reaction conditions was not quite, probably not quite designed for this complicated structure. I was having difficulty in purifying it from HPLC, and also, the most importantly, when I vac it down, it just deteriorate, or after reverse phases, sometimes just deteriorate the scaffold. So it's very annoying. And in terms of vacuuming it down, just let's say if we manage to get a pure version of it, then there's still difficulty in vacuuming it down. The freeze dry machine have limited slots and slots of submission, and the amount of solvents we get normally after purification would be like minimum like 200 ml for like a 10 milligram product. It's very difficult. I've tried other conditions, but just didn't work. Then I figure out, well, maybe I should give up on starting with a amine. Probably we can start straight from the AZ595 alcohol. From the original Hergen-Roses paper, it reported that if we combine the tosyl chloride and pyridine together, and reflux a little bit, it will work. And some of the conditions are just room temperature work. But I've tried with a building block. And it did work in terms of that condition. But when it comes to the more complicated, complete version of AZ595, or its enantiomer derivative, it just didn't work. So I was thinking, oh, maybe I should try just tosylate it first, then separate it, then do the pyridine reflux. It probably would work this way, but then I do have managed to get the conditions right for the first step, tosylated version, and for the next step, I just didn't get it. I can't find an osmotic peak. There's only one product peak I can find, is the 392. It took me a long time to figure out what the structure could be. I eventually got 6.1 milligram of this compound, and get a proton NMR, and this is the proposed structure, because I do not see the traditional methyl peak on here, but I at a different chemical shift, a methyl at a different chemical shift, and while I can see I shifted aromatic ring further down, so I would suspect the pyridinium does happen, pyridylation does happen, but there are some other groups fall off. that's why we can have the mass 392. Yeah, and it's exactly the mass. So if I've tried some other analysis, but no matter how we cut off the structure, it will either be 393 or 391. So I would suspect this is the pyridinium structure, but having the phenyl group fall off and the methyl group fall off. That's my suspicion, but cannot guarantee. So far, that's all I have achieved. That's it. Any suggestions or?
I'm kind of wondering whether sometime in the future, whether there's any sort of enthusiasm for trying to link some of the more potent versions of these things onto things like onto a siderophore, such as a catecholamine, simply because, I mean, the really potent ones are really, really fantastic inhibitors. And it is all about the permeation. So a siderophore might do the trick in getting the compound in.
Sorry. Let me note it down. What's that?
So just go to Shinogi's cafidrocol strategy and have a look at what they did with cafidrocol. It's sticking a siderophore onto a beta-lactam. You do have the vulnerability of resistance to siderophore permeation, but
yeah, they've
got a siderophore. Oh, right. So you mean siderophones, attaching siderophones? Sorry, I didn't hear very clearly. Yeah. Oh, the siderophones, according to the original Hamid paper, they have tried potent siderophones, but it didn't work out that way. So I can show you the analysis. Yeah, the siderophones. So I think, yeah, they have tried siderophones down here. If you guys can see it. The potencies were good, but in terms of MICs are not right there. So I think these will be the last parts I tried for this side chain. I'll move on to other designs, like not making the core a bit smaller and and try with the helix. Yeah, because I think so far on this side chain, I think we've done enough exploration, and as soon as the full length data coming out, and then we'll probably say, hey, maybe the design is not quite worth it, but I don't know. In terms of the analysis, I think it might be worth sharing. So my hypothesis for this kind of binding is like on the right hand of this structure, it's pretty rigid and held in place in the pocket, while this side, this side where the side chain sits, and we're exploring this side, we have a hydrophobic pocket to hold the phenyl group. We have hydrophilic interactions or pocket potentially on the other side, on the other branch, so we can have this compound sitting that place nicely. That's my suspicion, because the charged groups on the side chain kind of like make it less potent than we were expecting. So, and last time I remember, Adrian, you mentioned that maybe the charged parts was the problem, like getting this whole compound into the MUC protein. So I just based on that, I have this idea. Yeah.
I mean, the comment was really that if you put an amine on there, then you will probably introduce a pH dependency on permeation if there was any permeation, simply because it might depend upon the protonation of that amine.
Yeah, and also like permeation criteria are so different.
Yeah.
Ferrins one were like more suitable for the E. coli, and Helen's GERS criteria were totally different, and they actually they have opposite designs, more flexible and less charge, and C log D is different as well. The range as they prediction. So it's a lot to there's a lot to explore. So the design of chapter 3 will soon come out for the permeation and multi-targeting. That's everything. Thank you.
Sorry, I was late. I just had to be at another place. Anything remaining to be discussed, or it's on Yuhang and I think, to go back to CC4 carb to kick off that program. We've just got to go in with some specific designs, so that's on us, but that should be kicking off pretty soon. I'm in touch with a couple of people about whether there is interest in setting up a service for accumulation measurements. I think we mentioned this last time. There's no central service for that, but I'm talking to some people who are interested in doing that, and they're interested in gathering use cases. So people who would be interested in a bacterial accumulation assay, and why. So if you want to add your voice to that list, just let me know and I can mail.
Yeah.
I'm just going to say Annette von Delft at Centre for Medicines Discovery in Oxford.
Yeah.
They are thinking about trying to set up that assay as an open thing.
Indeed, and they're trying to that's the group they're trying to gather users to try and convince people to fund it.
Yeah.
They find
Yeah. I wrote a failed application with Frank and Carol Robinson about pre-COVID. So the application's written. It just failed on not being in scope as relevant.
All right.
It was a good application.
well, it is, maybe they think it's more relevant now.
Yeah, I think well.
Yeah, exactly.
The technology's moved on a little bit.
But still hard, right? I mean, it's still difficult. So yeah.
It's hard. It's hard because it's a classic example of when you want to take the measurement, you're interfering with the system. So you've got to process the organisms. You can't just, make the measurement without perturbing the compound concentrations.
Right.
So things get perturbed.
Yeah. So I guess there's no sort of standard control compound you can use, I would imagine. It's all relative, there's no.
Don't know. I don't know. I just remember going along to a meeting with Paul Hergenrother and Helena Zaskar and David Sixt, and they were all talking about each of the 3 different methods they had and the strengths and weaknesses of each of them. It was almost like you needed to run all 3 methods to get an average.
Right.
Inevitably, centrifuging, how spinning out cells, and then trying to get the intracellular concentration of compound out. Yeah.
So do you need extra projects for that, or?
Yeah, I guess I guess Annette is interested in who might have projects that would use that. And as a list to try and convince someone, I think the university, to fund it for a bit and show that it's worth it. Yeah, I think they have the equipment and the people, they just don't have any salary.
Okay.
We started doing this with LifeArc again pre-COVID, and they were working with University of British Columbia and then they gave up because it was too hard.
Right.
I guess it's worth giving a try.
All right, Yuhang, I wasn't sure what you got up to, but anything else?
Oh, sorry. I think I have one more question, if you guys don't mind. For Laura, I think previously in a meeting you mentioned that some of the WRH 86 or 88, those are the amines and the guanidines. You were saying that those compounds also target on TB. You saw some activities against.
Not TB.
Oh.
Give me a second.
Oh, sorry. Yeah.
And I can check exactly what was the compound. If not, I can send you later what's the.
Oh yeah.
Because it might be just easier.
Yeah. Thanks. And no more questions.
Yeah.
Thank you, everyone.
Yeah, and I can confirm. I can't remember how potent it was. Not very potent, like anything else. But I did ask Jenny if she could start growing smegmatis again, so we can retest some of the compounds from the project. Maybe we can direct it that way. And I also have TB proteins purified as well. So if we wanted to do assays to validate any TB interactions, then that's, except for Mur D, the other ones are ready.
Okay, yeah, that's great.
Mur D, I've got some pellets ready to purify, which I want to do tomorrow. Yeah.
Right.
Yeah, I'm currently working on the optimized series from the previous one that I sent before. So we designed a few analogs basically with potentially improve the solubility, which was a big issue when Adrian was doing the assays. So yeah, I'm working on that now. I should have a couple of compounds in the next, I don't know, hopefully a couple of months, maybe.
Good.
Yeah, I'm trying to by the end of the year have at least a
Okay.
set of new compounds. Yeah.
Yeah, and I am also gonna try to get some structures done for them. If I get anything, obviously for the TV, I will share it with you so you can use it as a model for your.
Yeah, that'll be nice.
Yeah.
And these are Mur compounds, yeah?
Yeah. I also send some of the compounds that were tested for solubility testing, so we can actually have a better information. Yeah, better estimation on what to prioritize and help us guide the design.
Sounds good.
Yeah, thanks.
Okay, don't let me take over, but if there's nothing else.
I think that's everything. If you want, maybe we can discuss the enable after we stop the recording, or
Sure.
We don't have any updates. We just
Okay. All right, great.